So here's the diagram. It's going to take a while to figure this out, so let's just start going for it. So starting over here, because these two lengths are the same, therefore these two angles are the same. 180 minus 40 is 140, divided by two equal angles gives us 70 degrees each. So 70 here and a 70 here, which tells us this angle inside here is 20 degrees. We can also figure out this angle over here. So 90 and 33, which makes this one here equal to 57, which makes this one here equal to 33. And we can figure out this angle over here as well. So 180 minus 86 minus 33 gives us 61 degrees in here. And that'll give us half the materials, plus this length, plus the original half as well. So if we can figure out this half of the structure plus times it by 2 and then add this middle bar, then we'll figure out everything. So the only distance we were given is the 5.7, so we'll use that to solve for first let's solve for this bottom one, this inside stuff. So using the let's use cosine law, or just cosine specifically, cosine of 33 degrees, this one in here, that's equal to adjacent, which is the 5.7, over the hypotenuse, which is this long one here, which we'll call x. So therefore x is equal to 5.7 divided by cosine of 33, which equals 6.8 meters. So we have that one here. Now we need to figure out these two inside here. And to do that, I can use the sine law to figure out either one of these. Actually, they're both of these exactly the same. So let's call this y here. So let's do that measurement. And so we have y over sine of 70 will be equal to 3.8 over sine of 40. Therefore, y is equal to 3.8 times sine of 70 over sine of 40, which roughly equals to 5.6 meters. So we have 5.6, 5.6, 5.7, and 6.8. The only thing left to figure out is this middle bar here. And to do that, I have a length and I have angle, so I can use sine law in there as well. Let's call this z. So to solve this, let's see. I'll use sine law, specifically x, which we found of 6.8 over sine of its opposite angle is 86, is equal to z, which is the unknown that we want, over sine of 61. So therefore z is equal to 6.8 times sine of 61 over sine of 86, which when we plug this into our calculator, we get it's roughly equal to 6.0. Alright, so now we've calculated all of our diagonals here. So to figure out, so y plus 5.7 plus x times 2. So the total will be equal to 2 times 2y plus x plus, what was it again, 5.7. That gives us this one, this one, this one, this one, times 2, so this one, this one, this one, this one, hence the times 2, plus the middle bar of z, which is here. So plugging in the numbers that we have just found, we get 2 times 5.6, that's y, plus x, which was 6.8, plus 5.7, plus z being 6.0. Plugging this all into your calculator, or just doing it by hand if you'd like, we get a final value of 53.4 meters. This is roughly because these values were all rounded.